In this lesson, we're going to focus on RESTful web services, in particular on how REST can be considered as an API. In front of you, you see in my Emacs editor yet again, one of the working files. This one is called rest.txt, and it does some summary points. I'd like to use this mostly as reference. I'm not going to go through it top to bottom, but I am going to start up at the top because the central concept, the core idea in RESTful services is the resource. And a resource is any informational item that has an identifier. So for example, I'm going to use the Acme company's product list, a fictitious company in our case, as the resource. 3 quick points about a resource. Quite obviously, the resource has to be hosted on some network machine that's accessible to clients. Typically, for example, a product list would be stored in a database. Those details don't matter to us so much. The important thing is that the host machine can be reached. So for example, it has an IP address, in this case, www.acme.com. Finally, for the very quick summary, any resource has various representations. In web services, we're interested typically in text representations, that is, in documents. But for example, Acme's product list could be represented by a movie, by a slideshow of images, and so on. Now, I'd like to turn to HTTP support for resources, but I'd like to do that by drawing parallels between how HTTP supports REST-style web services and how programming languages, in particular Java, supports the kind of things that you and I do as programmers. So for example, HTTP has so-called URIs, Uniform Resource Identifiers. These are the counterparts, for example, of variable names, class names, package names, and so on, the things that we're so familiar with in a language such as Java. In Java, of course, there are rules. So for example, if you have a package name in Java such as java.util.concurrent, the period is used as a separator. In the case of URIs, the slash is typically used as a separator, but you could also use a colon. There are various rules, various possibilities. So for example, our resource could be identified as /acme/products. URLs and so-called URNs, N for name, are subtypes of URIs. You and I, in our everyday business, mostly use URLs, but as we'll see later, a typical URL, although it is a URI, also includes a URI as a part, but we'll come back to that later. In all of programming, we're familiar with operations. So for example, some operations, arithmetic, comparison, that sort of thing, are relatively low level. There are fancier operations, sorting a tree, for example, that kind of thing. The counterparts of those operations in HTTP, these are operations on, of course, resources, named, identified resources. These are the so-called HTTP methods, nowadays commonly called verbs, because URIs are thought of as nouns. Now, among these operations in HTTP, 4 are particularly important because they cover the so-called CRUD operations: create, read, update, and delete. And what I have roughly in the middle of the document are examples. So you see, for example, post/acme/products. The 4 examples you see there are, by the way, basically the start lines of HTTP requests. So these start with the verb, then comes, if you like, the noun, the URI. By the way, some of the information, for example, the information needed to create a new product would be in the body of the post request. Similarly, if you look at the delete request, the ID of the particular product to delete would be included elsewhere in that request. Of interest to us right now is that we have HTTP methods that cover the basic CRUD operations, the counterpart of operations in a programming language. Now, in a language such as Java, we have explicit data types: int, float, double, char, string, that sort of thing. In HTTP, the so-called MIME types, multiple internet mail extension types, are used to type payloads, HTTP response payloads in particular. And you're familiar with these types. You've seen them often, I'm sure. For example, text/XML is one such type. Technically, text would be the type, XML would be the subtype, application would be the type, JSON would be the subtype. If you take all possible combinations of type and subtype, ones that make sense, you have in the ballpark of 4,000 MIME types. That's huge. Finally, HTTP supports status codes, which are a way for the client to be notified about how a request fared. So, for example, if I send a GET request over to some website or web service, I hope I'm going to get back a status code of 201, which means OK. We're all familiar with the status code 404, which basically means the server couldn't find what we were requesting. And if you're a programmer, you've occasionally run into that 505, which is server error. Let me summarize. One of the reasons you can look at REST as an API for web services is that REST derives underlying support from HTTP. HTTP has identifiers, URIs. It has operations, which are the so-called HTTP methods. It has data types for payloads, and it has status codes to record how a given request fared.